Solving quadratic equations by factoring. In the last video, you learned how to evaluate quadratic functions in standard form. That is, you learned how to find a value for y when given a value for x. Now what if instead we are given a value for y and want to find for x? This is called solving for x. We've done this before when working with other equations like linears of the form y equals m times x plus b. For example, suppose we want to solve the equation y equals 4 times x minus 5 for x when given y equals 23. To do this, we would replace y with 23 and then perform the opposite operations in the reverse order until we get x by itself. A two-step process you should be familiar with. Take a look back at a quadratic equation in standard form. When solving these type of equations, our goal is still to get x by itself in order to know what it equals. But the way we do it is a little different, since as you can see, we have x in two places in the equation instead of one. This makes isolating the variable quite difficult, but still possible. There are three different methods we use to solve for x in quadratic equations. They are factoring, completing the square, and the quadratic formula. In this video, I will be explaining how to solve quadratics by the first method, factoring. Let's get started. Think about the term factor for a second. What does factor usually mean in mathematics? If you remember correctly, factors of a given number are one of two or more numbers that when multiplied together produce a given product. For example, 2 and 6 when multiplied together produce a product of 12. And hence are factors of 12 just like 3 and 4 are factors of 12. Factors do not just apply to numbers. It is also possible to find factors of equations or expressions using the product of two smaller equations. A quadratic is no exception. A quadratic equation in standard form can be expressed as a product of two linears. Check it out. Let's take two random linear equations and multiply them together. To do this, we need to distribute. If you are unsure how to do this, check out one of my other videos called the distributive property. Anyways, after multiplying the linear equations together, distributing each term within one parenthesis with the terms in the other, we get a quadratic equation. This means we can express all quadratics as a product of its factors. This is significant because we can more easily solve for x when the factors of the quadratics are set equal to 0. Let's take a look at the quadratic we had earlier in factored form. This form of a quadratic is best used when trying to solve for x when given y equals 0. That's because if we replace y with 0 in the equation, we limit what x can equal in order to make the statement true. You see, 0 is only the product of two numbers when either one or both of the factors are equal to 0 as well. If neither are equal to 0, then we wouldn't be able to say their product is 0. This helps us greatly by allowing us to set 2x plus 1 equal to 0 and x plus 4 equal to 0. We can now solve to find two different possibilities for what x can equal. In this case, x equals negative 1/2 and x equals negative 4. So what does this mean? Can there really be two different answers for x? Why, yes, although one answer may not make sense in a given context. Think about the graph of a quadratic for a second. When given an input, x, you can find a single output, y, for that value. But when given y, the output, you have two possible values for x. Can I use factoring to solve for x when given other values for y not equal to 0? Well, yes and no. If you want to solve for x for another given value of y other than 0, you need to manipulate the expression so that in the end the product of the factors are set equal to 0. For example, suppose we want to solve for x in the equation y equals x squared plus 9x plus 22, given y equals 2. Replacing y with 2 in the equation will give us 2 is equal to x squared plus 9x plus 22. Now to set the expression equal to 0, we need to take 2 away from the left and the right side of the equation. leaving us with 0 is equal to x squared plus 9x plus 20. We can then factor the quadratic and solve for x. How exactly do you find the factors of a quadratic equation? Well, this in itself can be a complicated process. For now, we are going to look at finding factors of quadratic equations that have a coefficient of 1 in front of x squared. Looking back at the quadratic equation mentioned earlier, y equals x squared plus 9x plus 20, the factored form will look like y equals x plus a times x plus b, where a and b, when multiplied together, equal 20, and when added together, equal 9. To find these two such numbers, a good starting place is brainstorming all the factors of 20. When we do that, we get 1, 20, 2, 10, and 4 and 5. From these factors, I notice the only ones that also add to 9 are 4 and 5. This means the factored quadratic is y equals x plus 4 times x plus 5. I can double check by multiplying these factors out to confirm that yes, indeed, these equations are equivalent. I hope you have learned a lot about how to solve quadratic equations through factoring. Check out my other videos on how to solve quadratic equations by completing the square and the quadratic formula. Until then, see you later.